Good afternoon. So we are Team Flip Flop, and we're all about increasing the lab experience and maintaining the lab experiences under conditions of limited resources. So this might be when you have increased enrollment and limitations on space. This may be an online class or an online laboratory, or your students may be remote. So our three big ideas on how to do this is going to be, number one, flipping as much non-necessary content out of the lab as possible. Number two, using remotely controlled laboratories as a good use of time and resources. And number three, establishing at-home labs where students can do it yourself and still learn a lot about the content that we're hoping to deliver. So the first part, the first idea, flipping out. Things that we've identified that you could flip out include safety demonstrations and safety instructions, demos, getting the students familiar with the equipment so that they can go in and use their time wisely, and then delivering the theory and the content online in flipped lectures. This also would include simulations, getting the students to connect the theory with the experiment, make predictions using simulation software. And we'd like to identify best practices to do all these for easy adoption.
The second way that we thought about doing this, and actually several of our group members already have tried this in their institutions, is doing remote implementation of this labs through remote control of the equipment, say a robotic arm, an electron microscope, through a web-based interface. So some of the key issues that they already faced was the interface obviously needs to be secure, and it needs to have a good connection to have real-time interaction with the hardware. The advantage of this is the equipment is available 24/7, so you're not limited by the physical space and by the time. So at this point, students can use it overnight or whenever they want. And some of the things that our colleagues have pointed out is what really helps is implementing a collaborative platform. So you still give students not only the experience of controlling the equipment, but of having the peer-to-peer interactions during the lab, so they can sort of control it together through a platform where they can chat and do things. And one of our colleagues said that as he implemented this for the first time, one of the biggest complaints he had from students were, well, I didn't actually touch the equipment. So what we found important is to have sort of lab zero, where the students go in and actually touch the equipment. They might not operate it for as much as they're going to do later, but they had this one-to-one experience with the real equipment. So in a way, it's sort of important to, if an engine runs, it's important to smell it or feel the vibration. Maybe get your hands a little bit dirty, clean them up, and then do it via internet. So the third approach we thought about was, well, how about just doing the labs at home? So this is a sort of lab experience, as Tamara said, for remote students. So if you think about large online programs that might require undergraduate, say mechanical engineering or material science program. And also in a way, you could think about these type of labs enhancing your normal classroom and bridging sort of the experience from classroom to real-world engineering to sort of, oh, how does my fridge work? Well, I've been learning about fluids, so how about I take it apart or do something along with it? So obviously here, a few things that pop up that we had shared we think is shared across different disciplines is these labs will have to be very quantifiable. So how do you do that? One idea that comes to mind is to having an affordable modular sensor kit. One way to do it maybe is through something like smartphone-based sensors and having additions. But then you have to come up with ideas, is it affordable? Does everyone have a cell phone, right? So, and another thing is, you might not necessarily be able to ship everyone each kit for each lab. So can you use home-based resources that might vary from region to region? So example here is actually from my class where I use this is a centrifugal pump with a transparent housing. We can't send that to each student. But if you think about appliances and common things that you have in your kitchen, you have a lot of thermofluidic machines there. So can you use these as a way to integrate them into these labs? Obviously, it has to be safe and accessible. So going beyond TA-graded reports, maybe doing things like video and peer-to-peer grading. So what do we want from you? Besides extra 10 seconds, create a forum, for example, for shared experiences, and essentially create a database of ideas. When we introduce these concepts to people, right away someone says, well, you know, at home you can do that. Well, how about generating a database that people could share? This would apply also to kids' sensor software as well as assessment. So it doesn't necessarily have to be through the Frontiers of Engineering Education website. There's also places like DUI Network, Instructables, and so on. So what we would like from you is to identify a good place to do that. And at this point, I'll be glad to take any questions along with my teammates.
I love it. It's great. Quick resource. This group called iLabs. I can't remember what it stands for at MIT.
That was going to be our group name.
Funny.
We thought it was already taken.
It was. Kirky DeLong at MIT. I can connect you with her. She went to a whole hackathon that I threw for this idea. It's great stuff.
Part of what you do with controllability in labs is you're trying to adjust one variable to watch as one or more variables are changing. Is there concern if you're doing this at home that they're going to spoil their food in the fridge or burn their toast, or is there a way to get enough variable change in the things that consumer electronics have been built to remove the idiocy of messing those things up?
Right, well, that's always a concern, right? But I think we can identify sets of, equipment or resources that, through the community, hopefully with generating a bunch of ideas, we can identify things where we have those things, where you can control an independent parameter and look at the dependent variables. So maybe not a toaster with no adjustments, but maybe a toaster with adjustments, or a toaster oven, or where you can change the temperature setting and look at how long did it take to get to a certain temperature.
And also,
There's plenty of
in a way, you have to be careful about assuming what do people have at home, right? This might vary by region and region, but in a way, it might not necessarily be a restriction, but it might be an opportunity. You might think of it, let's say we're talking about Arizona versus Florida, dehumidifiers, or how does your AC run, right? Well, for me, my AC, the amount of power it takes to dehumidify my house is close to zero. In Florida, that's good 30–40% in the summer. So these regional differences might actually be an interesting opportunity to start discussion if you're doing a large online classroom. Come here.
I would just add to that I mean, it's not necessarily has to be appliance-based. It could just be things like measuring the heat capacity of a potato and other things that are in your fridge.
Where one of our colleagues from Maryland suggested, for example, how long does it take for a can of tasty beverage to cool down to room temperature, or to heat up to room temperature? Why does it take it out? Things along these lines that are simple. Could be simple, everyone has.
So just to comment, there's been a huge amount of K-12 resources developed along these themes. And as someone who teaches freshmen, juniors, and grad students, honestly, a lot of those resources, if you add a little bit more math or a little bit more intensity or a little more measurement, are very effective at multiple levels. So I would encourage you to look at existing databases for K-12 resources, the homeschool community, things like NiceNet, which are more specialized but also cut across a range of disciplines, where there's very well-developed content and kits, because a lot of the K-12 content, if you're talking about underserved schools, you want to be sustainable. So a lot of us have worked on grants where the goal is things teachers can get from Walmart inexpensively to teach concepts.
Exactly.
Thank you.
Perhaps in parallel with the remotely controlled laboratories, did you guys also consider just purely simulated laboratory settings?
Yes, that was one point that I think we discussed thoroughly. And actually one of the, in a way, you can think of just replacing the lab by simulations. But then the point was, you lose a little bit of touch. So absolutely, the simulations we thought about incorporating into the pre-lab, for sure, as a very useful way of, before you touch the real system and sort of play around with it, here's the system simulation, change the variables, this is what's going to happen. Now go and see what happens in reality. That type of, so absolutely, I don't think we highlighted. This may be enough.
Yeah, and maybe just add, one of the things about the simulations that we talked about was there's like a stochasticity about real experiments that sometimes the simulations, the simple ones, don't capture, and we wanted students to sort of have to go through that. It doesn't work, what do I do?
I broke it, what happened?
That's a great idea, the remote lab. I was just wondering, one of the things that people learn in the lab is when they make mistakes. What happens, so in this particular case, we will basically remove the element of them learning by making mistakes because it's remote. They can't really change anything in the lab. So how would you address that?
I would argue that they can make mistakes. It might cost them a little bit of money to fix that fridge afterwards. But, or the beer will be flat and not good, right? But I think you can make mistakes. I would say, I don't want a cookie cutter lab. I want it to be still relatively open-ended. And I think it's even more open-ended when you have variation from home to home. So in a way, you actually remove constraints that you have in a normal lab, which are extremely predefined, extremely controlled, to actually, this becomes a challenge from the grading standpoint. It is inherently a little bit less defined once you remove these constraints that you have in lab, where this is the same piece of equipment for every student. And I think with this variability, there might be a little bit more actual room to make mistakes, which is good. Like I say, people learn from mistakes.
I would like to add something. We're doing that in the control systems lab in ASU, and I want them to make mistakes. And the mistake is not, placing the cable in the wrong spot. That's obviously something that cannot be done in the remote lab. But I want them, for example, to put gains in the controller to come up with an unstable system and see exactly what it means to have an unstable system. So I want them to make mistakes, and I think the idea of the remote labs allows to do. Actually, it's even better because you can run the lab 100 times. You don't have only one attempt or two attempts that they have in the regular lab. So you can run the lab 100 times and you can literally do many mistakes and see what's the result of that.
One more question?